So let's look at 3 and 4. These are transformations of the function f of x equals b to the x power. So you got to ask yourself, all right, what's going on? I've got negative 5 to the x minus 2 power. So what's the negative in front going to do? What's the minus 2 going to do? Well, the negative in front is an x-axis reflection. So let me just write that down. I've got an x-axis reflection. And then that minus 2, remember that does the opposite of what we think. The minus 2, you would think it'd go left 2, but no, this is going to go, it's going to shift right 2 spots. So in the margin over here, I'm going to actually make a little table of x and 5 to the x power for my f of x. And so if I put in 0, I'll get 1. If I put in negative 1, I get 1/5. If I put in 1, I get 5. If I put in 2, I'm going to have 5 squared, which is 25, which is already off the graph. Okay? So if I graph that, I would be at negative 1/5, 0, 1, and I'm going to do these very small, very light. 1, 5 would be here, and then 2, 25 is off my graph. I know that what's going to happen is this is going to be shifted right 2 and then an x-axis reflection. So if I start with negative 1/5, I go right 2 spots and then reflect it over the x-axis. I'm just below the x-axis right here at positive 1, negative 1/5. 0, 1, I go 2 to the right and I reflect it over the x-axis. And I'm right here at 2, negative 1. 1, 5 would have been here. I go 2 to the right, and I'm going to reflect over the x-axis. Since I'm 5 above, I'm going to go 5 below, which would put me right here. So the graph of this is going down very quickly, and it's heading toward 4, negative 25 here. As I go to the left, it's going to hug the x-axis. That's my asymptote here. So my domain is still going to be all real numbers, but my range now, instead of being y greater than 0, since I have that x-axis reflection, I have y less than 0. That should be a little bit more rounded also. And my asymptote is still going to be y equals 0. Number 4. F of x equals 2 to the negative x power minus 3. So the negative on the x here gives me a y-axis reflection. Sorry about the shaking of the camera there. Hopefully that'll clear up. Got y-axis reflection, and then this minus 3 is going to shift everything down 3 spots. Down 3. So to the left here in the margin, I'm going to make a table for x and 2 to the x power, which we've already done several times. 2, 4, 3, 8, negative 1, 1/2. So let's put those in very light. 1, 2, 2, 4, and 3, 8. Okay. So I'm going to have a y-axis reflection, and then I'm going to shift it down 3. So let's start with this point. Y-axis reflections, I'm going to flip it from negative 1, 1/2 to positive 1, 1/2, and I'm going to go 1, 2, 3 down. And this gives me the point here. 0, 1, y-axis reflection won't affect that at all, but down 3, 1, 2, 3 puts me at 0, negative 2. What's my next point? 1, 2. I'm going to go across the y-axis to negative 1, 2, and then 1, 2, 3 down. It's me right here at negative 1, negative 1. 2, 4. Shift across the y-axis. Since I'm 2 to the right, I'll go 2 to the left, and now go down 3 spots. Puts me at negative 2, positive 1. And then 3, 8. I'm going to go negative 3, 8, and then down 3. Puts me at negative 3, 5. my asymptote is shifted down as well. Instead of being y equals 0, it is now going to be y equals -3, and I'm going to kind of draw that in since it's not the x-axis anymore. My domain's still all real numbers. My range will be, instead of y greater than 0, y greater than -3. So this is heading down this way. Getting closer and closer to that asymptote of y equals -3. Okay, one last thing about number 4 before we move on. I did want to point out that this could just as easily, this 2 to the negative x minus 3, could just as easily been written as 1/2 to the x power minus 3. Because if we took that negative exponent, change 2, take the reciprocal of 2, we get 1/2. So 1/2 to the x power minus 3 is exactly the same graph as 2 to the negative x minus 3. All right, so let's move on to number 5. So I've got 2 times 1/3 to the x plus 4 power plus 2. So what's going on here? Well, I have 2 times this, so I have a vertical stretch of 2. I'm going to be multiplying y times 2 each time. The plus 4 here means I'm going to be shifting left 4. And the plus 2 says I'm going to shift up 2. So let's make ourselves a little table here with x and 1/3 to the x power. Make that better, x. Alright, so if I put in 0, clearly I get 1. If I put in 1, I get 1/3. If I put in -1, I get 3. If I put in -2, I get 9. Alright, so let's put those points on very lightly here. So I've got 0, 1, 1, 1/3, -1, 3, -2, 9. So each of these points I'm going to shift 4 left. I'm going to multiply that y value by 2, and then I'm going to shift it up 2. Notice I'm going to multiply by 2 first, and then I'm going to add 2. So let's start with 0, 1. If I go 4 to the left, 1, 2, 3, 4, I multiply the y value by 2, so instead of having a value of 1, it's going to have a value of 2, and then I'm going to shift it up 2. So that should put me at -4, 4. -1, 3, I shift 4 places to the left, 1, 2, 3, 4. I'm going to double my value of y, so right now I'm at 3, which will double it. That'll put me up at 6. And then shift it up 2, puts me right here. Clearly when I do 9, I mean I can shift it for this -2, 9, I can shift 4 to the left, that's not a problem, but when I double it I'm going to be way off my graph, so that's not even going to be helpful. This 1/3, positive 1, 1/3, I go 4 to the left, 1, 2, 3, 1, 2, 3, 4 is right here. I double it, well 1/3 double is only 2/3, and then I go up 2, puts me right here. My asymptote is going to be y is equal to 2. Y equals 0 usually, but I'm shifting everything up 2. So let me write down y equals 2. Let's draw in y equals 2. And let's draw that graph in. So this thing is coming down, and it's going to follow that asymptote, go big to the left. Domain, still all real numbers. My range now is going to be y greater than 2. All right? Okay, let's look at number 6. F of x equals 4 to the 4 minus x power. 4 to the 4 minus x power. So I'm going to rewrite that. I'm going to write that as 4 to the -x plus 4. Negative in front of the x and the exponent tells me x-axis reflection. plus 4. Up on the exponent tells me shifting left 4. And I think that's about it. Let's make ourselves a table here. X, 4 to the x power. So 0, 1, negative 1 is going to give me 1/4. 1/4. If I put 2, I'm already off the graph with 16. Okay, so let's make just very lightly 1/4, negative 1, 1/4. I'm going to do x-axis reflection, and then I'm going to go left 4. So if clearly 0, 1 does not, x-axis reflection doesn't affect that. I'm going to go 4 to the left, 1, 2, 3, 4, puts me right here. The 1/4, when I do an x-axis reflection, puts me at negative 1/4, and now 4 to the left, 1, 2, 3, 4, puts me here. X-axis reflection on negative 1, 1/4 puts me at positive 1, 1/4, and now shifting 4 to the left, 1, 2, 3, 4, be right here. So I can tell I'm going to have all real numbers. There's no up or down shift, so my range is still y greater than 0, and my asymptote's y equals 0, the x-axis. And there we go. All right, these last two problems were reversing things. Now, given the graph, we want to come up with the equation of that function. So, what I notice on number 7 here, I'm going to center this a little bit. What I notice on number 7 is that my asymptote is at y equals 2. So I know I have been shifted up 2 spots. My 2 points given to me are negative 5, 3, negative 6, 3, and this point would be negative 5, 1, 2, 3, 4, 5, 6, 7. Right? This first point acts as basically where my y-intercept should be. It's that 0, 1 point that is on, the basic exponential function always goes through 0, 1, and that's going to be like my 0, 1 point, so I know that things have been shifted 6 to the left. That tells me things have been shifted 6 to the left. So in general, I know that my function is going to be some base. I don't know what the base is yet. The base, and I've got x. 6 left means it's going to be a plus 6 there, and 2 up means it's going to be a big plus 2 here. So in general, it's going to look like that. I just have to figure out what b is. So I'm going to plug that point negative 5, 7 in. I'm going to put in 7 for my y. I'm going to put negative 5 for my x. Oops, meant to be a b there, sorry. Negative 5 plus 6 plus 2. And I've got 7 equals b to the first power plus 2. If I subtract 2 from both sides, I get that 5 is equal to b. And so my function, rewriting my function, f of x equals 5 to the x plus 6 power plus 2. All right. Same sort of thing on this one. I can see that my asymptote, let me center this. You can see that my asymptote is going to be down here at negative 5. So it's been shifted down 5. And I've got 2 points here. My first point is 4, negative 4. My second point is 2, 4. So this is my, theoretically, kind of like my y-axis. So everything's been shifted 4 to the right. So down 5 and 4 right. So in general, I'm going to just use y instead of f of x here. Y is equal to b. This will be right 5 means it's going to be, right 4 is going to be minus 4, and down 5 will be a minus 5. And now I'm going to plug in this 0.24. So 4 is equal to b to the 2 minus 4 power minus 5. I want to add 5 to the other side. That gives me 9. 2 minus 4 is a negative 2, so b to the negative 2 power here. Okay. Remember, solving these, to get rid of that negative 2, I can multiply by its reciprocal. I can raise to a reciprocal power. And the reciprocal of negative 2 would be negative 1/2. So I'm going to raise to the negative 1/2 power on both sides. Negative 2 times negative 1/2 is 1. That gives me b. 9 to the negative 1/2. Well, that's like 1 over 9 to the positive 1/2. And positive 1/2, that's going to be the square root of 9. So b is equal to 1/3. My answer, I'll write it over here a little bit to the side, f of x equals 1/3 to the x minus 4 power minus 5. Okay, notice on number 7, our b value is greater than 1 because it is an increasing function. On number 8, we have a decreasing function. Our b value must be between 0 and 1. Has to be less than 1, greater than 0. That is it.